Okay, what we have right here is we're going to go through using the law of sines um, to figure out an application problem. You find a lot of these problems in your book, and you can see this is probably coming from a book that might be a popular one that you might be using. But it's a good old bridge design problem, and you usually are crossing over a lake. And what you create is an oblique triangle, something like this. They have north, south, east, and west that way. It says the bridge is built across a small lake from a gazebo to a dock. All right, so here's the gazebo, and here's the dock. Oh, that's just wonderful. The bearings from the gazebo to the dock is south, 41 degrees west. So what we're talking about when you're looking at this, all right, if you kind of think about that, we're going to go south, so it's going straight down, and then to the west, west to the left. And so what we create is this right here, and that's the dock, and that's where we get our angle right there. From a tree 100 meters from the gazebo, right there. A bearing of the gazebo from the dock is, once again, going up and down. Southeast, now we have this right there, which is 74 degrees. And we'll have one southeast, E respectively, and that goes from the tree to the dock. And find the distance of the gazebo to the dock. So we're trying to figure out this distance, I call it D, from the gazebo to the dock. Now, the key thing whenever you're doing problems with these directional components of south, east, or north, west, and so on and so forth, you have to realize that this and this are parallel. Okay, they are parallel. And that's going to be really important. And the reason why it's important is that you're going to use some information that you know, all right, about parallel lines. And from here to here, and this is why we're going to be saying it, is that we know that this angle and this angle, okay, that angle and that angle are actually going to be equal. So this is going to be 74, all right, degrees, okay? And so what we know also from right here, okay, and since these are parallel, this is 74 degrees, so we know that this angle is going to be 74 minus 180. And so this right there, okay, and if I can kind of take this and erase it a little bit, since this angle coming out is going to be, all right, up right there, and we have that one right there, okay, this angle is going to be 74 degrees because these are parallel, going down right there. This is our transversal. Well, then this angle right here, from here to here, is going to equal 180 minus 74 degrees. 74 degrees. Okay? Which we know is going to equal 106 degrees. All right, so this is 106 degrees. Well, what we know is that we're trying to figure out D, and if we have one side and we know the angles and we know one side, we can figure out all those different angles, we can actually figure out what the, we can use law of sines because we know that angle up to that one, then we have this angle on this side, and so that's why we're going to try to find all the angles inside. Okay, and so if we know that this whole thing is 106 degrees, then this angle inside the triangle, we'll call that angle, I don't know, we'll call it B, okay? So the measure of angle B is going to equal actually 106 minus 41. All right, 106 minus 41. And if you have 106 minus 41, that's actually going to equal 65 degrees. 65 degrees. And just to verify, you can add those together, and 65 plus 41 equals that. So that's 65 degrees. And so we figured out that this angle inside is 65 degrees. This angle right here, since this is 74 minus 28, we'll call this angle A. The measure of angle A is going to equal 74 minus 28 degrees. Doing a little geometry here, all right? And what you have then is going to equal 46 degrees. Okay, so this angle A inside is 46 degrees. Well, we're almost there. Well, now we know, we'll call this angle C. We'll call this angle C. I guess we'll call that D. This is A. We'll call this A over here. Okay. We know the measure of angle C is going to equal 180 minus the quantity 46 plus 65. All right, and that's going to equal 69 degrees. Okay, 69 degrees. So now we have all the angles inside, and we have one side offset at 69 degrees. And since we're trying to find out A, which I did call D for originally, all right, but now we're trying to find A, this side right here, we're going to use the law of sines. So we did a lot of basic geometry there, but now we can take the sine of, let's just say, 46 degrees, because now we only have to use it for the triangle. Remember, we're only using the angles of the triangle. Okay, so that's the key. Over A, and that's going to equal the sine of 69 degrees over 10. Or say not 10, 100. And so from here, in order to find A, we now can take 100. So A is going to equal 100 times sine of 46 divided by the sine of 69. And when you put this in your calculator and you round to the nearest number, all right, whole number, you're going to have 77 meters is going to be your final answer. And that's how we do that. So the key thing whenever you're doing any problems like this, all right, is understand we have parallel lines, use the angles, and find all the angles inside the triangle. That is the secret. All right, find the angles, use the side, and then use the law of sines to figure this out. All right, well, I hope this helps you out on how to solve similar problems to this. And yeah, we'll have some more tutorials, and you can check out the other tutorials on my other videos. All right, have a good day.